Hello mathematicians, we're now going to have a look at the quadratic formula and the graph. And again, you've seen the quadratic formula before, so if we have an equation y equals ax squared plus bx plus c, then we know that the roots of that equation are the values of x that make y equal to 0, which is graphically the location of the points where the graph cuts the axis. Now, the formula for determining those values of x is this one, which you should know, but I'm going to set you a little puzzle, which is, and I might ask you about it tomorrow, to tell me about how you derive that, or can you derive it? I'll tell you how, and it's by completing the square. So you need to take this expression, use our skills from the previous section, complete the square, do the algebra, and end up with this formula. Now, when you do end up with that formula, the things that we need to know about the formula are that the part under the square root sign, which is b squared minus 4ac, is called the discriminant. And the discriminant is crucial in describing the graph. So the two roots are going to be minus b on 2a, this part here, minus b on 2a plus the square root of the discriminant, and minus b on 2a minus the square root of the discriminant. So the two roots are symmetrical about, the two roots if they exist, are symmetrical about this axis of symmetry, minus b on 2a. So before we actually use the quadratic formula, it's often worth calculating the discriminant first, because if the discriminant is negative, if it's less than 0, there aren't any zeros. The parabola doesn't cut the axis at all. If the discriminant equals 0, then there's only one 0, and it occurs at minus b on 2a. And as we said, if the discriminant is greater than 0, then we have our two roots symmetrically placed about the axis of symmetry. So let's have a look at these two equations, two examples. So for our first example here, we glance at this and we can see it's a parabola which is concave down. We could rearrange complete the square and see whether we had roots or not by looking at where the vertex is. But it's probably quicker just to initially find the discriminant. So the discriminant is b squared, which is 6 squared minus 4ac, so that's minus 4 times minus 1, which is plus 4 times 1. So the discriminant is that. So we are going to have solutions to this equation, to the quadratic formula, because the discriminant is greater than 0. And we'll have two solutions. So just complete the quadratic formula then. X is minus b, so that's minus 6 plus or minus the square root of b squared minus 4ac over 2a. Tidy that up. So I've got minus 6 plus or minus square root of 40. And the square root of 40, if we think of two numbers that multiply to 40, one of which we can take the square root of, then of course this becomes 2 root 10, and that's over minus 2. And if we can factorize it, we do. So can I take out something from both terms in the top? Remember the finger breaker. Both terms in the top, which will cancel out with the negative 2. And of course I could take out negative 2, and that will give me 3 plus or minus root 10 over negative 2. So the two roots are 3 plus or minus root 10. Now it's interesting to note that when the number under the square root sign is not a perfect square, then we had to use the quadratic formula. There's no way we would have guessed two numbers. But if the number under here is a perfect square, we would have been able to use the product sum method to factorize this, as long as we could guess those two numbers. Let's have a look at this one. So what are our two zeros? So find the discriminant first. Let me rub that out. So the discriminant is b squared, which is minus 6 squared minus 4ac, so 4 times 3 times 4, which is going to be 48. So that discriminant is a negative. I can't take the square root of a negative. There are no zeros. There's no point pushing on with the quadratic formula for this. That doesn't mean we can't sketch it. We can certainly sketch this parabola, but we're not going to have points where we cut the x-axis. What we could do is to say our parabola cuts the y-axis at 4. It's concave up. I could locate the vertex. So the vertex is at minus b. So minus 6 on 2a. So that's going to be plus 6 on 6. So the vertex is at 1. But it must be like that. What's the y-coordinate of that vertex? Well, once I know that the x-coordinate is 1, then I can put it back into this equation. So that will be 3 minus 6, which is minus 3, plus 4, which is plus 1, which all fits. So we can sketch the parabola. You may want to think about this. I don't use it very often. In fact, I'd say never. But the vertex can always be found by this as well. I think it's quicker to find the x value of the vertex and stick it into this equation. But why do they say that the y value of the vertex is minus the discriminant over 4a? There's puzzle part 2 for tomorrow.